Alright, so distance time graphs. We talked about these briefly the other day. We said that we were going to start looking at them. So we did conversion graphs, but now these are distance time graphs and there's also velocity time graphs. So, these graphs show movement of an object over a period of time. Time is always going to be on your horizontal axis. So if you ever say to me, which one's which? Time is always the horizontal way. Okay, so as time is progressing, what's happening to the distance that we're travelling? Okay? So, it's a blank graph.
It's a black top
So nothing's happened. It wasn't a question.
It was
I said
Was it you?
yeah.
I thought it was Erin.
I said increasing.
So,
Which one's X and Y? Is Y this one?
no, darling, there is no X and Y. It's time and distance.
But the x-axis is the
The
horizontal.
horizontal one is time. That's usually our x-axis. Okay?
Yeah, Miss Harrison. This is what we're doing in physics right now too.
We did conversion graphs last time. So yeah, these are, when I sent you and you looked, a lot of you went, I'm thinking, I think a lot of you do physics. You physics.
Yeah, we did this last lesson in physics.
Oh really? Look at the timing. Alright, so lines on the graph can help tell us about the speed of the object. Okay? So, if you recall or if you're thinking about it, as the time is progressing and the distance we're travelling, if our line is steep, it means that we're not taking a lot of time to travel a big distance. Does that make sense? So if it's steep, we've not had a lot of time, but we've travelled a long distance. If our line is like this, it means that we have taken quite a long time to travel a short distance. So that means that can tell us something about the speed of something. Because if you've gone a far distance in not much time, it means you must be travelling speedily, yes? At a high speed.
Yeah.
Same meter and rate, yes?
Yes.
So, the other thing that we think about is if it's a horizontal line, okay? Well, let me backtrack. If it's a straight line, it means that the speed is constant, okay? So you're travelling at a constant speed if it's straight. If it does this, it means that your speed is not constant, okay? Most of the graphs, in fact, I think all of the graphs you're going to see are straight lines, so don't need to worry too much about that. But if the graph is horizontal, it means that your object is not moving, it's stationary, okay? This one is stationary with an A, not stationary with an E, which are the envelope terms of stationary. Okay?
What's a stationary that stationary?
Stationary with an E. That's why I always remember it's an E for envelope. An envelope is in that category.
Oh, it is?
And so stationary with an E is that. Stationary with an A is where you're stopped. Okay? So, if it's horizontal, it's not moving. Which again also makes sense because time is ticking along and the distance you're travelling is not changing. So if time is ticking and the distance you travel is not moving, it must mean you're stopped. Yes? What's it?
I was just remembering when Haley was stationary. When you said, oh, what? Gum in your mouth.
It's fake. That's not healthy, is it?
I remember everyone else said
Who said it's so hot?
I second that opinion. Never mind.
It's off. Why are you even joining in?
Because she wants it on.
You want it off? Take your jumper off too.
It's okay.
Alright, so the steeper the line,
Alright.
girls, please. If you're hot, take your jumper off. The steeper the line, the faster it's moving, the more shallow, more slowly. Okay, so just a reminder that speed is distance over time. Let's have a look at this graph here. So this graph represents Catherine's journey from Manchester to London. Okay? She stopped once on her way at the service station. If you are not sure what a service station is, does it matter?
No.
No. Okay? I can tell you, however, I'm trying to encourage you that when you're in a test or an exam situation, some people read things and go, oh, well, I cannot even attempt this question because I've got no idea what a service station is.
It doesn't matter.
Or, I've never been to Manchester, so I don't know what we're talking about. Or, I don't know where London and Manchester are, I can't do this question. So we have to make sure that in our heads, we're not allowing things like this to affect our application. What are you doing, Faye?
Okay, I was going to tell you something, but I mean, it's to do with that, but it's not to do with it at the same time.
So do you want to tell me afterwards when we're not videoing and recording this whole thing?
Embarrassing, you'll see.
I'd rather tell
Are
them
you
my
trying to put it
class.
on YouTube for your new channel?
Well, it's
Yeah.
about my grandparents, so.
They live in Manchester. Your
Well, what, my
grandfather-
grandpa lives in Manchester, my
Yeah,
grandma lives in
that's
London.
There we go. So this could be, is her name Catherine? Maybe she was travelling from London to Manchester, Manchester to
Service
London to
station.
see him.
Maybe.
You never know. So the service station is a rest stop, so where you can get gas, where you have food, snacks
Knew it.
along the motorway
Knew it.
or the highway. All right, so this axis here says the distance in miles from Manchester. This is the time. So they've actually done this in actual time periods. Now, whenever we're doing these kinds of questions, it's very important that you have a look to see about the scales. So I can see that this is 10 a.m. This is 11 a.m. How many baby squares are there in between those two things? Three. So those three squares represent 1 hour. Yes? So what does one baby square represent?
20 minutes.
Thank you, Katie. So 1 square is 20 minutes on the horizontal. Okay? Now, I've said that because I hear so many people say to me, I don't know what that number is, I don't know. So before you start these kinds of questions, it's really important that you actually have an awareness of what to do. This one here we've got from 0 to 50, and we've got, 1, 2, 3, 4 squares. So again, it can be a bit challenging. You need to be establishing how much each of those is representing. What would each of those represent?
I don't
A bit
know.
harder. Okay, well, why don't we say what half of that would be, which is 2?
25.
So that would be 25, and so we're looking at half of that again.
12.5. Each box is 12.5.
Okay, so
12.5.
12, well, I'm not quite sure where we got 4 from.
I just thought of 25 goes into 100 4 times. Wait, that's a lie.
Okay,
15.
but we're happy that it's not that?
Yeah.
Okay, so each of our squares represents 12.5 miles. Okay, so that's, again, just something you want to think about. We haven't even answered any questions yet. So it says, at what time did she stop at the service station? So what did we say indicates that something is stationary or someone is stopped?
A horizontal line.
Thank you. Haley's on board today.
I'm on fire.
On fire. So where does this
Fuego.
stationary line start? Well, it's here, and it starts down here. So what time is that?
11:40.
11:40. I love it. I love your work. 11:40 a.m. Because look, it's 2 squares away from 11 a.m. Are you with me, sister?
So, sister?
That's where she finishes her break. Are you with me? And then the next question says, for how long did she stop? So she stopped just one chunk, one square. So Miss Rossa,
Which is 20 minutes.
I totally believe there is just one person in here called Miss Rossa.
Oh, I'm sorry. I didn't hear that.
So that would be 20 minutes. All right. Next question. At what speed was Catherine travelling when she was going the fastest? So we have to have a look up here and decide, right, which one or where is she going the fastest? Is it this bit? Is it this bit? Is it this bit? Excuse me, or is it this bit? Sydney. Oh, one second. Complete side note. Can you please at some point just remind me to give your sister a merit? Okay?
Why?
Just seeing you reminds me. Okay, and I'm going to forget. Sorry, tell me again, what did you just say?
The first part.
The first part. Okay, so Sydney's suggesting this one. Is it 100% definite this is the steepest bit?
It could be the next, not that next
Yeah.
bit.
I mean, my personal thing is like, I'd kind of be a bit, is it this one or this
Yeah,
one?
that's what I
Okay? Now, if you're not sure, then you just find the speed of both of them. Now, we know that speed is distance over time, yes? And we can see that for this portion here, the green portion, the distance that she's travelled goes from here up to here. So what distance is
125.
that?
125.
125 miles. And then this portion here is the time that she's taken, yes?
An
What's
hour
that?
and 40 minutes.
And
An hour 40. So she's travelled 150 miles.
No, 125 miles.
Oh, sugar popsicles, thank you.
No, fire.
125 miles in 1 hour and 40 minutes. Okay, so that's the green portion. I'll come back to the calculation in a second. The blue portion, just in case, let's just double check. So what measurement did she travel between here and here?
12 o'clock to about 100 and...
My angel, I'm excited about your enthusiasm to answer, but the question was, how far did she travel?
She traveled
25 miles.
162.5.
What? 125 miles to 150.
25 miles.
So this is 25 miles, and then this is another 12 and a half, isn't it?
Yeah.
Yes? So 25 plus 12 and a half. What's that?
That is, if I work out in my maths,
Wait.
125.
That's 37.5. It's 37.5.
37.5 I just
I did it in my head. Julia used her paper.
So 37.5 miles, and I've lost the whole thing.
Wait.
The board's just gone completely.
I have a question. Wait. Why wouldn't you just travel 25 miles and not 37.5? Like, why'd you add the 12.5?
Because that line goes all the way up to the
12.5.
To the what? To the,
next square.
yeah.
Look, this from here to here is 25. What? Right? From here to here is 12.5. Add that together, it equals 37.5.
Are you with me, sister?
Yep.
And then how long did she take to do that?
40 minutes. She takes, let's see, 12 to about...
I think you're doing this in the wrong box.
Wait.
I am, because my board has just gone completely haywire, and I've even lost.
Okay.
I've lost. Oh no, it's up here,
Hold on, Miss Harrison.
but it's just gone all of the dither.
Can I do the thingy for you?
No, because it didn't work. I've already done it once. It's supposed to fix it forever and ever. Amen. Right. So to find the speed, we need to know our speed is distance over time. We cannot use time like this, though, can we?
No.
It's a mixture of hour and minutes. So we can change that to be just hours. How do we do that?
It's 1.3.
Wouldn't it be easier
How do
to
you do that?
Wouldn't it be easier to do in minutes? Then you could just add
plus 40.
Oh, wait, what did she do?
It's an interesting concept, but that would be miles per minute, which all they've asked, and they actually haven't said which units. But is miles per minute a usual?
Oh, right, no.
Measure?
So you would times by...
So,
What would you do? You times by 60, right?
So almost 1.6 recurring. So this is a good thing. I'm sure we talked about this when we did speed distance time, didn't we?
Maybe, I just forget.
So we need to make sure we can do this. So if we've got 1 hour and 40 minutes, this 40-minute part is going to be 40 out of 60, yes?
Yeah.
So that is 2 out of 3. So we've got 1 and 2/3 hours. What?
Yep, that's...
so
what's the decimal? 1.67.
Now, you don't need to have it as a decimal, but if you wished it to be, it would be 1.6 recurring.
6, 6,
so can we just round it to 1.7?
That's going to change your answer. Okay? You need to be as accurate as possible, which is why I'm suggesting that you keep it as 1 and 2/3. So to find the speed, it's going to be 120.
It'd be speed distance.
So it's 125 over 1 and 2/3. Which one's that for? What? This is the green one.
Good lord.
First line.
But I thought we already...
No, we established what our miles were and what our time was. We haven't done that. This is the speed. It's 125 the miles over the distance, hours.
How do you make
I mean, that's
something?
fine.
How do you make something recurrent? Just like your
Don't, you put it as a fraction.
You really need to do it.
What's the answer to that? That's what I'm waiting for.
So I don't know. How about you?
Could be. Is that what you're telling me it is?
Yes, that's what it's like.
Okay, so now it tells me that's 75 miles per hour. What's up?
Why wasn't it speed over distance?
Speed is distance over time.
Where'd you get I got 187.5.
That says 125. That's very clear. That's 125.
Over one.
Let me see what's next. Have we all got different things?
Yeah. Yeah, I got 187.5.
Let me see.
I swear if you realize.
So divided by 1 and 2/3, it's not going to be 187.
Yeah.
No, it's 75. I've tried it on 3/5. But we all need to make sure that we can use our calculators properly.
Wait, 1, 2,
That's
5.
essential.
That's
Divided by. How do you do 1 and 1/3?
Fantastic. So open up a bracket.
How do you do 1 1/3 on your calculator?
that's
1 and 2/3.
Easy both. Alright, so this one we need to change both. What we need to change this one here to be hours as well. What did we say we had to do to something?
2/3 of an hour.
Good. So we would divide it by 60. So we're going to have 37.5 divided by 2/3.
What?
That's the second portion. That's the blue portion. You were convinced it was the green one, so you can leave it like that. You're like, no, I think that was the steepest. That's the fastest. I'm suggesting that remember the next one across looked a similar steepness, so we're just double checking which one's actually the fastest. Okay. So what is 37.5 divided by 2/3?
Wouldn't that be
When you say wouldn't it be, I don't have a calculator in front of me.
It's 56.2.
56.25.
Yes.
This is my cheap. So we don't care about that. We're going with the green option.
56.25.
40 minutes and hours.
How do you change a minute to an hour?
Not that deep. I know.
What's that face for?
That's 2/3. I don't know, because I don't know 40 divided by 60.
2/3, Angel. Yes,
I have an easy way of calculating which one is steeper.
please share.
Just like from the other line, just like keep it going to the 0. You get me?
I hear you, but
Wait!
I'm not sure that would work.
Because this one goes more this way.
Oh no!
So that means it's steeper.
Oh yes, I hear you.
The
Junior,
turns
why are
out
you crying?
I thought, I'm not playing, but I thought that was a calculation
Put
under.
down here.
Yeah.
Oh, you.
Ah,
What I did? That was silly.
Super silly.
And then I even did that part down there because I was like, what is she doing?
I don't know if this is different.
Oh my god, the chair says she.
What we learned in street life, we're asked to go up a certain amount of meters and then you can go to school.
It's totally yeah. Now, the important thing here though is that they did say at what speed was Catherine travelling at, so you need to find the speed no matter what. Okay, so once you've established which one's steeper, you do need to find the speed, so in our case it's 75 miles per hour.
Actually, never mind.
And what's wrong with you two?
Okay, so I didn't know it actually worked, but I had a pen mark on my hand, so I put glue on it to rub it off, and it actually worked, and now the pen mark is on the glue. That's so sick. And it's off,
And it's so relevant,
but it's so cool.
so distracting. It says for what part of the Catherine, for part of the journey, Catherine had to slow down because of traffic. Girls, stop it. For how many miles did she travel at this slower speed? So which one tells us this slower speed?
The most horizontal line.
Yeah, the most shallow.
So it's the one with the end part, the end section. It's the one before that section.
It's the one before the very
It's
end,
the-
yes?
It's the fourth
Okay,
line.
so how many miles did she travel in that section?
12.5.
How'd you get that, Hayley?
Because it only covered one box.
So it only covers one box vertically, so that would be 12.5 miles. Yes, we're all looking at that going, yes, 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 we get it. You said no?
Wait, how did you
I said no. So, in this portion here is where she's travelling the slowest. No, vertically. Because this is distance. So from here to here, she's only travelled 1 mile. Are you with me? Alright, now, this bit here is where lots of people, oh my goodness. This one is where lots of people make mistakes. Because they see this word and get all excited and travel back to statistics.
Oh, yes.
And they think that they want to try and find the mean. They want to add stuff up and divide by however many speeds they've got.
Yep.
Okay? No, not in these cases. In these cases, because they're asking us about the whole journey, you just need to establish what is her total distance that she's travelled over the whole journey and what is the total time taken. And that is including any stops. So all you need to do, I don't want to even move my board back to my original graph. All you need to do for this is to say, right, well, how far did she travel? So from 0 up to the very top of the graph, how far did she travel?
20 miles.
200.
I mean 200.
Okay, so she travelled 200 miles, yes?
Yes, sir.
By the end of the journey. So you must it.
Yes,
And how long did the journey take her in total?
4 hours and 20 minutes.
4 hours and 20 minutes.
Is it 4 hours 20?
Baby.
4 hours 20. Now, do we leave as 4 hours 20?
No.
No, we need to change it. So how do we do that? We deal with the minutes, so that's going to be 20 over 60. So we've got 4 hours and 1/3. Actually, that's not written very nicely. 4 and 1/3 hours.
So can we change that to an improper fraction?
You try to change that to an improper fraction. How would you change that? What would it be? Go, go, go.
It would be you do 4 times 3, which is 12 plus 1, so 13 over 3.
Yes. Alright, so chuck that in the count.
Wait, stop. Can I do it, guys?
No, nobody let Julia do it.
No, I did.
She's been mean.
What have I done?
What is it? 46.
I got 46.1538.
Oh, cool.
Yep.
As well.
Wow, that's awesome.
I got 46.153.
Tres biens. Okay, we're all getting the same kind of answer. Good with that?
Yeah.
Yep.
Okay.
Say that.
Lucy, so this one's nice for us to draw a distance time graph. So we've got Lucy cycles from Dockyard to her friend's house in St George's, which is 25 kilometres away. She starts at 1 p.m. and can cycle at an average speed of 10 kilometres per hour. On graph paper, use suitable axes to draw a graph of Lucy's journey. Time always goes along horizontal. From your graph, find out what time Lucy reaches her friend's house. Also find out what time she reaches Warwick, which is 10 kilometres from Dockyard Flats.
Oh, this is in Bermuda.
Sherlock.
She's a little bit daft.
Honestly, I'm with you, Danny. Sherlock has just got no worries with you around, has he? Now. So Lucy, we're assuming she's just cycling at an average speed of 10 kilometres. She's going 25 kilometres. So we're going to draw on our axes. So you're going to choose a good scale. You're going to use a ruler. Okay? You're going to have 0 here. And this is going to be distance
Should we use a pencil?
to St George's. Yes, you always use a pencil for thingy.
Whoops.
And you're going to use a suitable scale for on the bottom. Now, no. So you may want to establish how long is the journey going to take her. So she started at 1 and cycled 10 kilometres per hour and she's travelling 25 kilometres. How long is the journey going to take her?
It's I can distance and speed. God, I don't know the time. So that's distance over speed.
Don't you dare do that on the calculator.
It's 2.5.
You just typed in 25 divided by 10.
I have no
On a
self-trust,
calculator.
okay? I have no self-trust in myself.
So you just automatically did it. You didn't even think about it.
2.5.
So you need to have 2.5 hours worth on the bottom here.
I've done it myself.
So I'm going to leave it. All right. Okay. So once you've decided on your scale, which has taken some of you an hour, you then have a look at the information. So it says that she's traveling 25 kilometers at 10 kilometers per hour. So what you're going to do is on your graph, you're going to find, oh, for goodness sake, deep breath, Miss Harrison, deep breath.
Deep breath.
Okay, so you start here at 0, you're going to find 1 hour on your graph and find 10 kilometers on your graph and put a cross. And then you could potentially find another hour and another 10 kilometers and put another cross and then just join them up and extend your line. Okay, then you're going to say you need to answer the question. So it says how far away are those features. So you're going to find 10 kilometers on your vertical axis and read across until you hit your line and then tell me what time you get to Warwick Academy. Say similar thing for flats and then the causeway. Okay?
That's very sad.
Yeah.
But you could just.
Okay. So I'm going to let you now try this next question on your own because I can't possibly draw anything on this board. It's doing my head in. So let's go through the answers in a second once you've had a go at it. We're going to look at speed start graphs on Monday. I think it's just too much to do it today. I'm just losing the plot. No, tomorrow. Yeah, no, today is
Where's mine different?
Wait, Miss Harrison. So we look at speed time graphs on Monday. Okay?
What is this?
Okay, that's what I'm going to talk about next. When I finish my sentence. Alright. So homework assignment. I'm just going to